So hello people, welcome to this video. Let's solve the problem of the day. Well, today we are having letters collection. So let's read the problem. Problem statement says, the postmaster wants to write a program to answer the queries regarding letter collection in a city. A city is represented as a matrix mat of size n cross n. Okay. Each cell represents a house and contains letters which are denoted by a number in the cell. Fine. The program should answer Q queries, which are as the following types. Okay. So the query of type, which has three integers. The first one is number, number of the query, first or second. Then we have ij. You can say the location of cell. Okay. Then what we have to do is to sum all the letters which are at the one hop distance from the cell ij in any direction. All right. And for 2ij, we have to sum all the letters which are at 2 hop distance from the cell in any direction. We will see what we mean by that. The queries are given in a 2D matrix, queries, no problem. Okay. And these are the hop directions given. So let's try to understand what this question is saying. Here we have the examples. Let's try to calculate the answer for it. Seeing this example, we are given our n and m values, right? And the whole matrix here. Now the point of queries is here. Number of queries is given as 2, and this 2D matrix, which is actually having the queries, is here. So how do we read a query? Once we encounter query, we have three things written here: 1, 0, 1. This one means we're talking about the number of query, and then we have I and J. Correct? This is the address of cell in which we have to perform the query. Now for the second situation, we have 2, 0, 1. Correct? Let's solve the first query. The first query is to sum up all the elements at one hop distance. What do we mean by that? Okay, when we're talking about all the distances at one hop, that means we're talking about the 8 directions. What are the 8 directions? These ones. Okay. We have the 4 primary directions: the up, down, right, and left, and along with it, all the diagonal directions as well. So we need to cover each and every cell. If we are given 1, 0, 1, that means we have to perform the query in 0, 1 cell. What is the 0, 1 value here in this matrix? It is going to be this 2, correct? It is going to be this 2. So performing the first query on that would mean that we have to take each and every element that is present at one hop distance. That means these ones. That means these ones. Okay, what are the values? Values are 1 plus 5 plus 6 plus 7 plus 3. Right? And that results in 22, and that is given here. Correct? Okay. We could have had these values above as well, because that is out of the bound. That means that is beyond the boundary of the matrix. So we need to keep in mind that the boundary is there. All right, performing the second query, we have 2, 0, 1. Okay, 2 is not changing, but this time we have to perform the second query, right? So assuming 2 is the value that we are performing the query on, for that, we need to see all the elements which are at 2 hop distance. So let me mark the first hop one. After that, the next border. That means we are going to take this line. These are all at 2 hop distance. We cannot go here, correct? We cannot go here because this is out of the bound. Here, all these values, those are present. These are 9 plus 1 plus 3 plus 4 plus 8 plus 4, correct? Which will result in 29. So the problem is pretty simple. We just have to figure out how we have to travel this in a efficient manner. Okay, if we have to see one more example, the same thing is here. Here we are given a matrix, and then we are saying that we are going to be having only one query. The query is this. We have to perform the second query on 3, 2, on 3, 2. Third row, 0, 1, 2, 3, 3, 2, 0, 1, 2. That means this value. We have to perform a query in this 21. What will we do? We will see all the 2 hop elements. What are going to be the 2 hop elements? This time it is going to be this complete block, correct? Because all the 4 square that are being formed, these 2 rows and 2 columns for our 2 hop distance nodes, or you can say the cells, the whole thing is actually coming under the boundary in this one. That is why we are beginning from here. 7 plus 8 plus 9 plus 10 plus 11 plus 17, which goes up to adding all the things up till 13 here. Okay, and then we simply have to return the sum. Now, how are we going to do that? What is the approach? Very simply, I've made one cell here just to tell you once more what are we actually going to do. If assume this is your ij cell, this is your ij cell, and we are talking about the first query. That means the first hop. So the cell which are directly associated with are just adjacent to it in the 8 directions, including the diagonal directions. We have these values, correct? We have all these values. So we have to just travel it and we have to sum it up, correct? Now what if we are given the second query? Then we have to travel this complete matrix, this complete border, okay, which are at 2 hop distance, 1, 2, which are at 2 hop distance. Every element here is at 2 hop distance. Fine. Now, once we are given our I and j, what can we do? How can we travel these? Well, let's say if you're talking about the first query, that means we can do I minus 1 and j minus 1, right? I minus 1 and j minus 1. Where will this value get us? This value will get us here, correct? Similarly, I can go for I plus 1 and j plus 1. I will go to this cell, correct? Now I have I and j value of this, I have I and j value of this. I can simply travel like this from top to this end, this end line, correct? And I can simultaneously take this too and keep on summing it up. Then once I'm here, I can go from this to this direction because I will be having my j from here to here. Then I can move it from here to this cell. And along with this, we can parallelly add up these values, right? And eventually, when the sum is calculated, we have to return that. One more situation is there. What if my matrix is actually this much? Okay, is actually this much. And this being my ij value, actually is going to be including these many cells at one hop only. We do not have to calculate these. For this, just to avoid this, we can simply make a utility function, which usually go by valid. And we can, what we can do is we can just check the boundary of our ij matrix, and simply we will see if the ij value for the cell are going out of the bound, we are not going to consider them. We are not even going to access them, correct? Resulting in no error. So it is pretty simple. This is for the first or for the one hop, and the same thing can be done for the second hop as well. So if you are here, you can try figuring out this value by doing I minus 2 and j minus 2, and simply this value by doing I plus 2 and j plus 2. Once that is done, you just have to travel the boundary and we will get the sum of it, correct? So let's see how can we code that up. Well, here's the code for the same. What I've done is I have created one normal list, which is what will be containing my answer in the end. After all the queries are performed, I'll be returning that. Now comes for query in queries. That means I'm traveling all the queries and one by one we are executing all the queries. What I'm doing here is I have created an answer 0 just to keep the count of everything, to keep the summation of everything. Now I've taken these IJ, ILJL and IRJR. Told you which are these cells. These are the top left and bottom right cells, so that we can travel all the boundaries with the minimum efforts. Now what I'm doing here is I am traveling like this. Okay, and once I'm traveling this way, I can also travel this parallel way, right? That is what I'm doing here. I've taken up the queries. What I'm doing here is query 1 minus 0. That actually is I minus whatever the query is. If the query is 1, it will be I minus 1. If the query is 2, it will be I minus 2, right? I'll be having the values of these corner cells. What I'll do, I'll first of all run my I from IL to IR plus 1. That will take care of my rows, of both my rows. It will be adding these up. And how am I adding it? I've created a utility function valid here. I'm first checking that if the I and j are in the boundary of a matrix, only then I'm making the call and I'm adding the values. Okay. All right. This will be resulting in sum of both of these two, and this loop will be resulting in the sum of these two. Okay. Once we are traveling the columns. Fine. So eventually the answer will be containing the complete, you can say, boundary or the one hop boundary, depending upon the query. Eventually, what do we have to do? We have to append it to the result, because there could be several queries, and eventually we have to return the result. Talking about the complexity of the problem, well, it solely depends upon the number of queries. The number of queries we have, you just have to execute it, because there are fixed number of cells that we have to travel, correct, for the one hop as well as for the second hop. So let's try to run this code against test cases. Here we have the same code. Let's try to compile it. Okay, so it is giving us the desired output. Let's try to submit that to test it against all the test cases. Okay, so it has passed all the test cases. So the problem was quite simple. I hope you've understood it. And if you liked the video and the approach, do tell me in the comments. Thank you so much.